It is a silent Tuesday morning in the Strait of Hormuz. High above the atmosphere, a billion-dollar constellation of American reconnaissance satellites, the eyes of the Pentagon, are scanning every square inch of the Iranian coastline. On the screens at the National Geospatial Intelligence Agency, the feed is pristine. There is no movement, no missile launchers on the beaches, no activity in the ports. To the untrained eye, it looks like a thermal void, absolute silence. But this silence is a lie. Beneath the arid, sun-bleached peaks of the coastline, tucked under 100 feet of ancient, solid rock, the story is very different. Deep inside the earth, thousands of Iranian technicians are moving like clockwork. They are fueling the engines of 3,000 ballistic missiles, all of them pre-calculated and aimed directly at the coordinates of the U.S. Fifth Fleet. These aren't just bunkers, they are entire cities carved into the crust of the planet. We call them the sleeping dragons of the Zagros. For decades, the U.S. military doctrine has relied on the simple rule: we can see it, we can kill it. But what happens when the target is invisible? What happens when the most powerful air force in human history meets a fortress that refuses to appear on radar? How exactly do you destroy a threat that is buried so deep that even the most advanced thermal sensors can't detect the heat of a single engine? To answer that, we have to stop looking at the sky and start looking at the armor that protects these ghosts. In traditional warfare, a mountain is just an obstacle. But for the engineers of the IRGC, the Zagros Mountains are the ultimate ballistic shield. Usually, when the United States military decides to eliminate a high-value target, the solution is straightforward. They send in a B-2 Spirit or an F-35 to drop a 2,000-pound Mark 84 JDAM. On a standard reinforced concrete bunker, the result is catastrophic. The bomb impacts, the fuse delays for a millisecond, and the target is vaporized. But against the unsinkable fortress, that 2,000-pound bomb is nothing more than expensive fireworks. The reason lies in the geology of the Zagros itself. This isn't just dirt and gravel. We are talking about massive, tectonic layers of granite and limestone that have been compressed over millions of years. Granite has a compressive strength of over 200 megapascals. To put that in perspective, it is nearly 4 times stronger than the highest-grade reinforced concrete used in Western skyscrapers. When a standard cruise missile hits these slopes, the rock doesn't just absorb the impact. It reflects the energy back outward. The crystalline structure of the granite acts like a natural shock absorber, dispersing the kinetic energy of the explosion across the entire mountain range before it can even reach the tunnels below. Even if you hit the exact same spot 10 times, you're only scratching the surface of a shield that is miles thick. This is what engineers call overburden, the sheer weight and density of the earth that creates a permanent state of compression, making the rock even more resistant to fractures. This creates a terrifying tactical reality. The U.S. Navy can patrol the waters of Hormuz with its guided missile destroyers, and the Air Force can orbit the peaks with its most stealthy drones, but they are effectively punching at a ghost wrapped in a suit of indestructible armor. The traditional paveway laser-guided bombs that won the Gulf War are effectively neutralized by the sheer physics of the Iranian coast. But the Iranians didn't just stop at using the mountain as a roof. They realized that if the rock could protect them from the outside, the space inside could be transformed into something far more dangerous. To see how they turned a geological anomaly into a mechanical nightmare, we have to go deeper, past the granite skin and into the man-made labyrinth of the deep underground. Inside the Zagros, we aren't looking at simple bunkers. We are looking at what the IRGC calls City of Missiles, a sprawling, subterranean industrial complex that operates with the precision of a Swiss watch. But digging a hole is easy. Making that hole survivable against the most advanced bunker busters in the world, that is a masterpiece of hardened engineering. The first challenge is the shock wave. When a heavy munition impacts the surface, it creates a high-pressure front that travels through the air in the tunnels like a bullet. To counter this, Iranian architects utilize a zigzag geometry. By forcing the air to travel through a series of sharp, 90-degree turns, the kinetic energy of the blast is bled off against the reinforced walls. Every turn acts as a physical filter, degrading the pressure until it is harmless before it ever reaches the personnel. Then, there are the blast doors, massive, multi-ton steel bulkheads designed to seal in milliseconds, creating airtight, hardened structures that can survive even a thermobaric vacuum. But the biggest vulnerability isn't the explosives, it's the heat. Fueling a ballistic missile generates a massive thermal signature. To a high-resolution US reconnaissance satellite, that heat is a neon sign saying "strike here." To hide it, Iran employs sophisticated thermal masking. They use deep-bore heat exchangers that vent the exhaust of the missile prep areas into underground aquifers or decoy vents miles away from the actual launch site. And the logistics of this labyrinth? They don't use trucks. Trucks are slow and visible. They use a massive network of high-speed underground rails. Thousands of missiles are mounted on mobile launch platforms that sit on specialized tracks, allowing the entire arsenal to be repositioned across the mountain range in minutes. This is not just a storage facility. It is a living, breathing mechanical organism that stays cold, stays silent, and stays ready. But hiding is only half of the strategy. The real terror of the unsinkable fortress isn't just that it can survive a hit. It's that it can hit back and vanish before the American response can even clear the barrel. This is where we see the Iranian shoot-and-scoot doctrine in its most lethal form. Imagine you are a commander on a US guided missile destroyer in the Gulf. Your radar is clear. Your satellites are reporting no activity. Then, in the span of 3 seconds, the peak of a mountain 40 miles away literally splits open. This is pop-up warfare. Through a series of camouflaged, hydraulically actuated hatches that look identical to the surrounding rock, FAT-110 ballistic missile emerges. It is a cold, calculated 180-second window. In the first 60 seconds, the launcher clears the hatch. In the next 60, the guidance system locks onto the carrier group's coordinates and the solid fuel motor ignites. The launch is a violent, massive eruption of fire and smoke, a thermal spike so bright it triggers every early warning system in the US Central Command. But here is the twist that keeps Pentagon strategists awake at night. By the time the infrared sensors on a space-based infrared system satellite detect the launch, and by the time the Aegis combat system on a destroyer can calculate a counter-battery solution, the launcher is already gone. It doesn't drive away. It slides back down the rail system, retreating hundreds of feet into the gut of the mountain. The armored hatch slams shut, filled with a layer of synthetic rock that masks the cooling heat of the launch rail. When the American Tomahawk missiles arrive at the launch coordinates 4 minutes later, they find nothing. No launcher, no crew, just a cloud of smoke drifting over a wall of solid impenetrable granite. It is a tactical ghost story, a game of high-stakes whack-a-mole where the mole has a 500-kilogram warhead and the hammer is made of 5 miles of mountain. The US military's greatest advantage has always been its ability to achieve total information dominance, to see the battlefield better than the enemy. But inside the Zagros, that dominance hits a wall, literally. The IRGC has created a scenario where the American response is always too late, targeting a ghost that has already retreated into its shell. This stalemate has forced the US to stop thinking about how to find the missiles and start thinking about how to kill the mountain itself. And that brings us to the most terrifying weapon in the American arsenal. There is a profound irony in the modern theater of war. We have spent billions on high-resolution cameras that can read a license plate from space and thermal sensors that can detect a human heartbeat through a wall. Yet, in the Strait of Hormuz, all that digital power has been neutralized by the most primitive technology known to man, a hole in a rock. It is the cost of blindness, a billion-dollar failure of imagination. In our obsession with the digital, we forgot the physical. We were looking for pixels, while the enemy was moving mountains. For the first time in a century, the American hunter found itself staring at a wall of silence, unable to find the ghost in the machine. But the United States military does not accept a stalemate. It does not look at an impenetrable mountain and walk away. It simply changes the way it looks. Does America just give up? The answer is a cold, calculated no. If the eyes of the Pentagon were blinded by the rock, they decided to stop using eyes and start using ears, electronic ears that can hear the heartbeat of the mountain itself. This is the start of Phase 3, the seismic hunt. To find the invisible, the US has deployed a new generation of ground-penetrating radar, or GPR, mounted on specialized low-orbit drones. Standard radar bounces off the surface, but GPR pulses at specific frequencies that penetrate the granite, mapping the density of the Earth beneath the peaks. It looks for anomalies, hollow voids where there should be solid rock. But the Iranian architects were ready for this. They lined their tunnels with radar-absorbent materials and used specialized geometric baffles to confuse the signal. The US took it a step further. They began deploying massive arrays of subterranean seismic sensors across the seafloor in the neighboring islands. These sensors don't look for light, they look for vibration. Every time a 30-ton missile launcher moves on an underground rail, creates a microtremor, a signature vibration that travels through the crust. Using advanced AI algorithms, the Pentagon can isolate these tiny signals from the background noise of the ocean and the wind. It's a high-stakes digital duel. On one side, you have the Iranian architects, building deeper, using acoustic dampening and thermal insulation to stay silent. On the other, you have American data scientists, teaching machines to recognize the specific hum of a Fateh 110 engine through 200 feet of limestone. It is a grueling, invisible war of attrition where the prize is a set of coordinates. But here is the problem. Even with the most precise coordinates in the world, how do you kill something protected by a mountain? You can't use a scalpel. You can't use a standard missile. To break the unsinkable fortress, you need something that defies the very laws of geology. You need a weapon designed not just to hit a target, but to reach into the soul of the earth and rip it out. The answer isn't just a bigger bomb. It is a smarter, more brutal piece of physics. To kill the ghost, you don't use a scalpel. You use a 5,000-pound hammer. Enter the GBU-72 Advanced 5K Penetrator. For decades, the gold standard for bunker busting was the GBU-28, a weapon literally forged from surplus howitzer barrels. But the Zagros isn't just any bunker, it is a geological fortress. To crack it, the Pentagon needed more than just weight. They needed pure, unadulterated velocity. The GBU-72 is the apex predator of the subterranean world. When released from the belly of an F-15E Strike Eagle at high altitude, it doesn't just fall, it hunts. As it accelerates toward the Earth, the GPS-guided JDAM tail kit makes micro-adjustments to ensure a near-vertical impact angle. This is crucial. Every degree of tilt is lost energy. It needs to hit straight like a needle. Impact. The hardened steel nose cone, a masterpiece of metallurgical engineering designed to withstand pressures that would liquefy a standard tank, strikes the granite at supersonic speeds. It doesn't explode on contact. That would be a catastrophic waste of kinetic potential. Instead, it utilizes its massive forward momentum to literally punch through the tectonic layers. We are talking about 200 feet of solid, ancient earth, or 60 feet of reinforced, high-strength concrete. It digs, it grinds, it tunnels through the mountain's skin like a hot wire through wax. Only when the sophisticated internal sensors, the void-sensing fuses, detect a hollow space, the internal labyrinth of the missile city, does the warhead trigger. The result is not just a standard explosion. It is a catastrophic overpressure event. Inside the confined tunnels, the blast wave has nowhere to go. It reflects off the granite floors and zigzag ceilings, turning the very architecture meant to protect the crew into a lethal pressure cooker. The heat vaporizes the rocket fuel, the shockwave shatters the underground rails, and the vacuum effect sucks the oxygen out of every corridor in a heartbeat. In a single violent second, the unsinkable fortress becomes a subterranean tomb. The dragons are no longer sleeping, they are extinguished. This is the ultimate expression of technological dominance. It is a brutal message sent through 60 meters of solid stone. If you hide, we will find you. And if you bury it, we will dig it up. Boss, the Strait of Hormuz is no longer just a shipping lane. It is the most expensive and dangerous laboratory in human history. It is a never-ending cycle of mechanical and tactical escalation. Iran builds a wall, and America builds a bigger sledgehammer. Iran builds a deeper, more complex maze, and America builds a smarter, more sensitive ear. It is the ultimate game of cat and mouse, played with ballistic missiles and supersonic penetrators. Every year, the rock gets harder, the sensors get sharper, and the bombs get heavier. But in this theater of war, there is no final victory, only the next phase of the loop. We make original videos from scratch, decoded and animated by our small team to bring you the technical truth behind the headlines. If you want to understand the machines that define our world, stay tuned. The hunt is just beginning.